and welcome to the InfoQ podcast. My name is Wes Reisz and I chair the QCon Software Conference brought to you by InfoQ. The next conference is in New York in just a few days, but by the time this podcast airs, it will likely have passed. However, the next QCon Software Conference will be in San Francisco this November 5th through 7th. So if you like what you hear, join us for 3 days of technology deep dives and best practices in software. Today I'm talking to Matt Klein. Matt is a systems software engineer at Lyft. Before that, he was doing infrastructure work with software at places like Twitter and Amazon, and he's best known as the author of Envoy. The subject of today's podcast, we will be talking about understanding what Envoy is really being used for. We'll be answering questions that are raised about performance when leveraging a sidecar proxy approach in a service mesh. We'll talk about Envoy's design philosophy around things like observability and tracing. We'll talk a bit about the roadmap and finally some of Matt's thoughts on machine learning and how it may affect Envoy in the very near future. If you're grappling with framework concerns in a polyglot environment, considering moving cross-cutting concerns out of project libraries, even using edge proxies in your architecture, Envoy is one of the tools being used and considered at some of the world's largest software shops. Thank you for joining us, and I hope you enjoy this podcast.
Matt, welcome to the InfoQ podcast.
Thank you for having me.
So before we jump in, I was looking at the stats just literally this morning for QCon New York. Would it surprise you to know that your talk, Lyft's Envoy Embracing a Service Mesh, is the number one talk being added to people's schedule?
Wow, that's fantastic. That's great to hear.
Any thoughts on why Envoy resonated with the community so well?
You know, it's been a pretty amazing journey. I think when we open sourced, I had a pretty good idea that we were solving problems that a lot of people in the industry had, but I'm going to be honest in saying that, you know, the reaction that we've had since open sourcing almost 2 years ago at this point has been really beyond my wildest imagination. It's been a pretty incredible journey. I think it just really speaks to, you know, the fact that we have a lot of people who are rolling out microservice architectures, and there's a lot of common problems that people are facing that are not easy to solve. And, you know, Envoy in its current form and all the technologies that are being built around Envoy, they're by no means perfect, but they go a long way, you know, towards helping people roll out these architectures and actually realize the benefit of the microservice architecture that they had been promised.
So you said 2 years. It was September 2016, Envoy came out. What was the environment that Lyft was in that kind of gave birth to Envoy?
Yeah, well, I mean, we started development in Envoy over 3 years ago, actually. So we started development of Envoy in May of 2015. And, you know, at that time, I think Lyft was a pretty typical hypergrowth startup in the sense that we had a monolith, you know, that was written in PHP. Our data store was MongoDB at that time. And a lot of developers, when I joined, I think there was probably 70 or 80 developers. And, you know, since then, our development team has grown almost 10x. And at the time that I joined, even with kind of that relatively few number of developers, Lyft had started on its microservice journey. There was probably 20 or 30 services written in Python. And Lyft, fairly common from that time frame, was a polyglot architecture. So we had PHP services already written in Python. There was plans to bring on another language. At that time, there was discussion as to whether it was going to be Go or Java. And of course, you have other random services, Node.js for front end. So at that time, we were already seeing kind of this polyglot breakdown of, you know, not being able to rely on a single language. So we were kind of in an environment where people wanted to roll out their different services, but were facing common problems around observability, networking, not trusting the underlying network. And we're really in a situation in which I would say that the microservice rollout was stalled, right? Like people wanted to do it, but there were so many reliability problems from debugging, from just getting things to work, particularly around the networking observability perspective, that people didn't trust microservices. You know, and I had seen this evolution before at Twitter and before that back at Amazon. And I think I knew that there was a potential solution here, which was to run a piece of software that was not a library, to avoid kind of the library upgrade issues and having to rewrite that library in 4 or 5 or 6 different languages. So there was the potential to build a proxy here and kind of have that be the substrate. And, kind of the point of that was to build an abstract network. And that's what we set out to do.
You came from Twitter, so the finagle world. So you had a lot of these capabilities there that are offered by Envoy. Was it that polyglot that led you down this?
It's two things. And I think polyglot is the big one for sure, just because these libraries or these systems, they're just complicated. Like this is very complicated code. And, you either have to rewrite it in multiple languages or you have to kind of pick one language. But even if you have one language, I think people underestimate the kind of general library upgrade pains. And, we saw this at Twitter where people would develop Finagle. And again, don't get me wrong, there's nothing wrong with that library. It's a very impressive library. Same for Hystrix. But what you'll see with these libraries at many deployments is it may take 6 months, 9 months, 1 year for actually getting changes out. So if you're trying to do relatively rapid development, or if you're, for example, trying to roll out load balancing changes or tracing are things that might rely on making change to every service at once, having to deal with that upgrade cycle, even with one language, can be very complicated. So I think it's the combination of library upgrade pain and polyglot. I think those two things together just kind of made the outer process architecture approach fairly no-brainer.
Let's back up just a little bit, cover some basics, then we'll talk some more. When I think about Envoy and read about it and talk about it, it's a lot of things. I mean, it's a layer 7 sidecar proxy. It's a layer 4 communication bus. It does all kinds of things like routing. It does things like load balancing. It offers like circuit breakers, tracing and observability. It does a lot. What is the definition, Matt Klein's definition of Envoy? What is Envoy?
Oh, that's a tough one. I haven't been asked that one before. It's harder to say what Envoy is versus what I think the goal is. And I think what Envoy is what the goal is. And from my perspective, the goal of Envoy is to abstract the network from application programmers. I think, from an industry perspective, we're building big internet applications at this point. I think most organizations spend a considerable amount of time not writing business logic. Like I think they spend a lot of time fighting with getting their applications to work, with like figuring out how to monitor them, like how to scale them, how to
marshalling, unmarshalling.
There's just so many concerns. So from a business perspective, like if you're a product manager, any time that you're spending working on that stuff, it is effectively money wasted. Like you don't care about those things. You're not building product. So, from an infrastructure perspective, and this is not just Envoy, I think it's most of what we see in this cloud native infrastructure space, is that to the greatest extent possible, we're trying to abstract these things from, effectively from application programmers so that they can spend their time, building business logic, which is what, makes a company money. So from Envoy perspective, we're doing what it takes, focusing mostly on networking and observability, is to abstract as much of that, what I call plumbing, boring plumbing that people don't want to care about from a protocol perspective. We're trying to make it so that, application programmers don't need to worry about that. And that plumbing, of course, includes load balancing, and it includes routing, and it includes all types of different things. But that's where we draw that line. And I think one of the things that we've done with Envoy that has been really great is we've been very clear at this point about this is core Envoy, like this is the code that kind of is included in every Envoy instance. And then we have a pretty rich set of extensibility points. And those are for things like filters or access logging or different types of tracers or different types of stats backends. And what that allows people to do is basically mix and match and kind of know what's in the core code and kind of take the extra pieces of functionality that are important to them and then kind of build up their own system. And that kind of leads us into the second point, and this might be your follow-up question, which is that Envoy is a very complex piece of software, like which you pointed out. It does a lot of things. And I think sometimes there's a push and pull because we'll have people that'll come to the project and they'll look at the documentation. And I understand, documentation can always be better and getting started guides can always be better. And people will come, they'll have heard of Envoy and they'll say, wow, this is so many features. I don't even know where to start. And then the flip side is you'll have people that know a lot about networking and kind of building these systems, and they'll be, diving right in and they'll be trying to understand what's there and they'll be asking for different features. So even from a project perspective, it can be complicated to actually satisfy both types of people. And I think from kind of where we want to take Envoy is Envoy, we believe, can be a very powerful building block for building other systems. And that's really what we've seen over the last 2 years is at this point, we have probably 5 or 6 different startups that are building their products or more, that are building their products on top of Envoy. We have all the major cloud vendors that are beginning to offer Envoy as a service. So I actually think that, Envoy is becoming fairly ubiquitous, but I think a lot of times people won't even know that Envoy is actually running because it's being bundled as part of something larger. So I think that's fairly interesting.
So Envoy, basically you get containers and you run sidecar. So it's a one-to-one mapping typically between containers that you're running with Envoy. Is that right?
Well, I mean, again, that's where it gets kind of complicated. Like Envoy can really be run in a variety of different deployments. It can be run as an edge proxy. It can be run so by edge, I mean like internet facing. So, doing things like application firewalls or auth or rate limiting or, different types of traffic routing. It can be run as a service to service, quote, sidecar proxy. So next to a pod, though even there, it's technically possible to run Envoy on each host and then have all of the pods, for example, on that host talk to a local Envoy. It's possible to run Envoy in a middle proxy or kind of an internal network kind of center proxy configuration. And we see people run Envoy in all of these. Like at Lyft, we run Envoy on the edge. We also run it as a sidecar proxy. We have actually a couple of middle proxy deployments. It's a pretty versatile piece of software.
But where do you see people really starting? What is like a common entry point that people come into the Envoy world?
I would say there's probably 2 separate entry points. I think there's people, they want a more flexible edge proxy. So their situation. So, of course, we have Nginx, which is a great proxy. That's kind of the de facto edge proxy right now. There are certain deployment types or certain pieces of functionality that Envoy has that Nginx doesn't have. So I think we see some people coming in who actually are replacing Nginx at the edge, or they're in a cloud provider and the cloud provider's load balancer just doesn't have a particular feature that they want. So for example, maybe in Amazon, they're replacing the advanced load balancer with Envoy, or maybe in GCP, they're, taking Google's load balancer and they're swapping in Envoy. So we have that edge. I think that actually is a common entry point for people who are using Envoy. And then we have people who are starting to build quote service meshes. And, there's a big variety there. There's people that are doing it themselves. They're building their own control planes on top of Envoy. We obviously have people who are using Istio, which uses Envoy as its data plane. And then there's a bunch of other companies also. So I think we're actually seeing both. We're seeing both edge and service to service.
That was my next question. As you start to kind of lay out all the different products that are kind of in this space, you've got things that are service meshes. You mentioned Istio, you've got Conduit, you've got Linkerd out there, you've got a variety of tools, you've got proxies, HA proxy. When you're trying to get your mind around Envoy and what it is, it's all of these things. It could work with these things too, right?
Yeah. And this comes back to what I was saying before, which is we're not trying to build a singular product with Envoy. It's just not a project goal. And part of that is how we actually run the project. Like there's no single company that's actually running Envoy. Like it really is an entirely community-driven project. There's no open core, there's no enterprise solution. Like it's just all there. And because we've had, pretty massive community growth, it's honestly, incredibly amazing to me. I was looking today. I think we already have like over 180 contributors. I mean, it's really incredible just seeing the people that are coming together to build the software. But when you're community driven like that, of course, like we're not going to build Envoy into a database, right? But, when people come with reasonable features and given our extension system, we're going to allow people to build features that make sense. The flip side of that is that it is a very rich piece of software that isn't a single cohesive product that does one thing. Like it's not focusing on a plug and play Kubernetes experience. It's not focusing on a UI around edge routing. It's not focusing on performance, it's not focusing on security. It can be used as a foundational building block to build all of these products. And that's kind of what we're seeing. And that's why, again, I actually think it's likely that within a couple of years, I think Envoy will be running in a very large number of places, but I think most people won't be aware that they're even using Envoy. Like they'll be purchasing Envoy through some other product that happens to use Envoy as its base because it offers all of these features and all of this pluggability that allows people to differentiate and, have a UI or do this particular thing with like security or routing or something else.
So if it offers all these features and you can be using it for certain use cases, but not others, does that imply that, it's kind of process intensive, it's heavyweight? If you're running it service to service and every single container has to have a sister container, for example, is there a lot of performance impact or overhead from running?
That's a very common concern for people who are kind of looking at the service mesh architecture, which is, what's the perf like? And, it's absolutely true that if you're sending traffic on each hop through the system through an out of process proxy, there's cost to that. Like nothing's for free. And I think there's two separate things to actually say about that. The first thing is that what I tell people is that I think for 99.99% of applications, like in my opinion, unless you're literally doing high-speed trading, I think performance is important and I think people should do their benchmarking. But I think a lot of times people want to run some comfortable benchmarks. They want to do kind of what I call horse race benchmarks just to see that things aren't absolutely crazy. But then in production, the boxes aren't very heavily loaded. Like the services are written in Python. They're doing like 100 requests per second or something like that. It just ends up not being relevant. And when you look at all of the features that the proxy gives you, whether that's observability, load balancing, service discovery, like rate limiting, like on and on and on, that even if you're taking, I'm kind of making these numbers up because the numbers depend on what you're doing, but like even if you're adding, say, 1 millisecond per hop, for most infrastructures, if you're looking at an end-to-end call chain, that might take 200 milliseconds or like 300 milliseconds for most internet apps, 10 milliseconds of extra additional latency for all the features that you get it just doesn't mean anything. Like as engineers, we're trying to optimize obviously for performance, for engineering time. And like some of these tools can save you so much time that the extra cost it just doesn't matter. So that's my first point. The second point is that what we're seeing around Envoy is that people are doing some pretty incredible things around performance. There's the folks over at the Cilium project. So that's an open source, very kernel focused networking kind of system. And they're now using Envoy for a whole bunch of stuff. And they have some pretty incredible plans in terms of how to just make Envoy run faster. And kind of what they like to say is that Envoy itself isn't actually slow. It's the context switches, from the application to, to the kernel and the kernel to Envoy and like back and forth that end up taking all the time. And without getting into a crazy amount of detail, they're doing some really impressive engineering to kind of take out all of that extra kind of CPU cycles that are actually running there. So if you start extrapolating out, from a multi-year perspective, I actually think that, some of the folks that are doing all this kernel work, I think a lot of these timings can be cut down a lot. So that argument continues to fall apart. So I think between the fact that you just get so much out of the system versus what it's costing you and the fact that the cost will decrease over time, it's just not something that concerns me unless you're really counting single digit microseconds.
Dave Thomas, Andy Hunt's pragmatic programmer, talked about no evil wizards. So building systems and not having visibility into what's happening under the covers. There's a lot happening under the covers with Envoy. How do you address that? I mean, is there an address that? Is that something I have to accept, that it's an opinionated approach, that you're going to get HTTP2, you're going to get gRPC, you're going to get all these things for service to service operability, but I have to accept that? Or is it peeled back enough where I can get in there and be able to understand what's under there in the substrate?
Yeah. From a project perspective, you can basically configure everything, so we allow you to opt in to almost every feature. You can decide what type of load balancing you use. We emit an extremely rich set of stats, logs, etc. So our goal is to give people tools. It's not to tell people how to explicitly use those tools. And again, this comes back to what I was saying before, which is some people come to the project because they've heard about it, and I think they expect it just to solve their problems by default. Unfortunately, for most of these infrastructures, we're just not there yet as a larger industry. There just isn't one way of doing things. So it's impossible at the Envoy level to provide someone a config or a product that will do everything that they want. So I actually think that Envoy, yes, of course, it's opinionated in some ways in terms of what it does, but it actually allows an incredible amount of things to be configured. The flip side is that that's the hard to use. So we look for more opinionated products to be built on top, which are going to reduce some of those knobs and kind of hopefully guide people to better defaults for their particular deployment. So if you have someone who's running on Kubernetes, you can make a bunch of assumptions about how you can configure Envoy, right? Because Kubernetes works a particular way. Or if you're deploying on Cloud Foundry, that works a certain way. Or if you're deploying within Amazon Container Service. So I think that's where the closer that you get to how the software is deployed, how it's provisioned, I think you can get more and more opinionated. And that's where I think things can become easier for people. So when people start using kind of a PaaS, like a full platform, I think we can actually make things really opinionated because we know how people are deploying software. Like we actually know essentially what they're doing. But because Envoy is going to be usable in all these different environments and all of these different configurations, we can't actually do that for people. One other small point, though, is that there's also this idea that, because Envoy does all of these things, like it does timeouts, it does blah, 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 that application programmers just don't need to be aware of them. And that's not really true. Like if you're an application programmer, like of course I said that we want people to focus on business logic. That's what we want to happen. But you still likely have to be aware and somewhat knowledgeable about, you don't have to know how to implement them, but you have to know about things like retries and like timeouts and things like that. Because there are things without application knowledge that Envoy just can't know. Like it can't know if it's safe to retry a particular request. Like you can have rules, in different request types that say whether they're idempotent or not, but people often break those rules. So it's like Envoy doesn't make assumptions about whether a request is idempotent, for example. So users have to tell Envoy whether a request can be retried. So it's like, I don't think you're ever going to fully get away from application programmers kind of being aware of some of these concepts, but you can get away from them writing retry logic with exponential backoff. You can get away from them implementing service discovery and load balancing. So I don't think that Envoy makes these things disappear even in the future. It just makes it so that people don't have to worry as much about how they're actually implemented and that they're implemented consistently. And that's key, is that across your infrastructure, you want consistent implementation just because it makes debugging so much easier.
So speaking of debugging, and you just talked about emitting a ton of logging information in distributed tracing, I want to talk a bit about the story there, because most of what 2 years ago, a year ago, all the stories that we had at KubeCon was about how do we decompose this monolith? How do we break it down? Now the stories have kind of shifted in how do we operationalize microservices? How do we run them? How do we debug them? How do we find problems on this distributed path when you've got this Death Star architecture that you're trying to be able to operate? And I think that's one of the really, really compelling stories about Envoy. So can you talk a bit about the design philosophy around observability and tracing that Envoy kind of adopted with just the amount of metrics that it emits?
Yeah, and that can also be extremely overwhelming to people, as Envoy emits a lot of metrics. So, we built Envoy to run Lyft. So there's no features in Envoy at the time that we open source that we did not use at Lyft. Like, of course, now with like massive open source development, there's lots of features that people have added that we don't use at Lyft. But Envoy grew to be a product, that hundreds of developers at Lyft would use. So every stat that was added was basically added for a reason because we were trying to debug systems. I've been doing this for a long time. And one of the complications of actually like using HA Proxy or even Nginx can be, at least a couple of years ago, or some of the cloud load balancers, is that it could be fairly difficult to actually figure out what was going on in them. Like the stats output was not there, or there wasn't tracing, or, there's obviously logging. So I think our philosophy with Envoy is that we try very hard to emit information that are going to help people to actually run the system in production. And we've just used it a lot in production. So we have, from a logging perspective, like a really rich set of filters and sampling and the ability so that, because you just can't write 100% of proxy logs typically, or for tracing, the ability to figure out what actually gets traced so that things are kind of done in a way that's stable across multiple proxies. So I think, again, our goal there is just observability first. Like, I think that observability is probably one of the main goals, right? So it's like you're trying to abstract the network, but as we know, the network is not reliable and things are going to break. So when things break, we have to know what's going on so that we can kind of figure it out and we can fix it or kind of work around it. So we've just spent a lot of time on that for sure.
What about tracing? And what is the story around tracing with
Yeah, so what we do with tracing is we have a pluggable trace system. So just like we do for stats, you can essentially have different sets of backends. So when we open sourced Envoy, we only work with a single tracing backend, and that was a company called Lightstep, and that was just because we use Lightstep for tracing at Lyft here. But since open source, we've added Zipkin support, we've added an open tracing backend. So one of the nice things there is that Envoy basically has its own tracing abstraction layer. So Envoy can generate tracing data, and then from a user perspective, they can plug in their own tracing backend, whether, again, that be an open tracing, we'll get open census in the future, or Zipkin or Lightstep directly. And the way that I kind of view tracing is I don't personally think that we are there yet right now from tracing being as useful during like a pure operational firefighting perspective. I still think tracing is like a little difficult to use in terms of figuring out, how do I find the right trace that actually matches this particular event? But at Lyft, where we have found tracing to be just exceptionally useful is in like non-firefighting debugging. So looking into performance problems, just understanding what's going on. Like people, once you build these large architectures, sometimes people just don't know which services are actually calling them. So it's just an amazing way to help visualize what's actually going on and to debug, I would say, more difficult problems.
So the current version's 1.6. What's coming up? What's the roadmap look like?
Well, we're doing 1.7 release in probably a couple of weeks. To be totally honest with you, we have so much development now that I have a hard time keeping track.
That speaks to the community. That's great.
It's partly also due to how we do releases. We're a little odd from an open source perspective, just in the sense that we do releases because we know that people want releases, but they're honestly kind of arbitrary. We do them once every 3 months or so, just to kind of, it's like a point in time. We treat Envoy as master should be RC quality at basically all times. And that's because we all run master. I mean, like Lyft deploys Envoy master twice per week. We have other people who kind of, all basically do the same thing. So just because most of the rapid moving internet companies, they all deploy master. So, for most of the major contributors, it's important for us to keep it at high quality at all times. And that's the other reason why I have a hard time keeping track of releases, is because we're always running master. So I just don't know when things get added. But from a roadmap perspective, I think there's obviously other protocols that people would like to add. I think Kafka is one that will probably be pretty interesting. I think that there's going to be continued work on making more things automatic. I think one of the biggest problems that we see in Envoy deployments, and this is actually not really Envoy specific, I would say just in networking deployments or in service mesh deployments, is it's a very hard problem to actually set defaults, right? It's like, what's your error budget? How many retries should you allow? Like, how do you set your circuit breakers? How do you set your rate limits? And there's been some pretty interesting research and production use cases that have been done about kind of building more automatic systems to actually do this. So for example, Netflix has open sourced some code that they use, which basically does adaptive concurrency control. So instead of having every user go in and say, this is my circuit breaking limit or this is my rate limit, Envoy would be able to kind of dynamically determine what the actual throughput could be. And I think that we're just going to continue to focus on ease of operation, so that's going to be better debugging work. So we're going to be doing a bunch of work where you can ask Envoy in certain situations to emit like all types of debug information with each request. So where it got routed, what the internal timings are, things like that. The ability to basically have more settings, more like adaptive settings around concurrency, timeouts, additional protocol supports around things like Kafka. There's always a never-ending list of things.
Andrew Ng said artificial intelligence is the new electricity. It's going to change just like with electricity changing steam-powered engines. AI and ML is going to change everything that we're doing. How do you see machine learning changing this networking substrate mesh level?
So it's not just machine learning. I think in particular, it's what's happened in the last 10 years, which is neural networks. And I think that's what actually changes everything. Because prior to that, all of the different machine learning systems, they were effectively massive rule-based systems that were very difficult to program. And what I am most fascinated by right now, I think in the Envoy space, is Envoy obviously takes control. It can take control information and do a whole bunch of different things, but it can emit a ton of different information, whether that be logs or stats, or we're going to be adding in the future soon kind of a tapping system. So you'll be able to basically do TCP dump effectively through Envoy and kind of dump data, that matches certain types of parameters. And what those data sources can do, particularly with a neural network type learning system, is you can imagine Envoy is sending kind of sample data to a training system and is building models on the fly. And then as part of an anomaly detection system, whether that be for DDoS or for security or just for bad hosts or just for operational stuff, it becomes really completely technically possible to take this output data, be training a model. The model might be every 5 minutes, 10 minutes, 15 minutes. It might be every hour. It might look at times of day. But the idea is that we can train a model of what's normal for a system over time. And then as new data comes in, we can actually feed some of that sample data through this learning system and say, is it normal? And if it's not normal, let's flag this and actually look at it. So I think that we haven't really even scratched the surface of what's possible there in this area. And this is an area that I'm super excited about.
Yeah, the security, being able to say this thing is abnormal behavior, be able to take different actions.
Well, there's just so many applications, right? There's, from a security perspective, there's obviously just alerting, saying, okay, this is a little weird, like, probably should look at this. There's automatic remediation, right? So it's like you can imagine a next generation system, which is taking information, it's looking at the model, it's maybe actually trying to figure out, all of these requests are coming from this IP address or like has this headers or like this type of signature. Let's actually send Envoy back a block filter that will block this particular type of traffic, right? So you can have a feedback loop. Or even setting aside security, definitely possible to start looking at traffic patterns amongst hosts and to actually start saying, like this host is like a little weird. It's probably bad. Like maybe we should just kill it or something like that. So I just think that there are so many fascinating applications. And right now, if you look at kind of the current state of the art, at least from the open source perspective, it's still in the networking space, there's still a lot of hand configuration. Like I think there's a lot more that we can do that is effectively fully automated.
So by the time you hear this podcast, it'll probably be over. But here in just about a week and a half, Matt will be speaking at KubeCon New York. His talk is called Lyft's Envoy, Embracing a Service Mesh. So if you're at KubeCon, make sure you check it out. It's the #1 talk being added to the schedule right now. And if you miss it, it will be on InfoQ in a couple weeks following KubeCon. So Matt, thank you for taking the time to chat with us on the InfoQ podcast.
Thank you so much.